All right, we're going to get started with Chapter 9, Section 4. So that's 9.4, Changes in Dimension, and that starts on page 697. So the first thing is to scan the lesson and predict two things that you'll learn about changes in dimension. And the two things that we're going to look at are going to be effect on when we have changes in dimension, how it affects the perimeter and how it affects an area. All right, and I really like this example. I think it's a really nice way for you to see how perimeter works and how this whole concept goes. So it says, Mr. Blackwell is building a rectangular doghouse. The floor of the doghouse is 4 feet long and 2 feet wide. So draw the floor of the doghouse on the graph paper below. So we're going to do 2 feet, whoops, let me try and get this, 2 feet wide and 4 feet long. And I don't know if that's going to be up and down for you or side to side, but we'll just do up and down. So that we have the 2 feet wide and the 4 feet long. All right, now, don't forget our units. Now it says add the lengths to the sides to find the perimeter. So we should know that finding the perimeter of a rectangle is going to be 2 times the length plus 2 times the width. Okay? Since this other side, and the reason that it's 2 times is because we know that this other side is also 2, and that this other side is 4. So it's really going to be 2 times the 4s, and then 2 times the 2s. So 2 times 2 plus 2 times 4. We do the 2 times 2 first, which is 4. Then we do the 2 times 4, which is 8. And we end up with a 12-foot perimeter. So the answer number 2 is the perimeter is 12 feet. Number 3 says to multiply the length and the width to find the area. So we know the area is length times width, or base times height, and that we have, it'll be, oops, sorry about that. It'll be 2 times 4, and 2 times 4 is 8 square feet. So the area for the same thing is 8 square feet. So then Mr. Blackwell doubles the width of the doghouse. So originally it was 2 foot, but now he said, okay, I'm going to make it 4 feet. And he's leaving the length alone. Okay, so we're going to double the bottom, and so now we've got 4 feet on the bottom, and 4 feet is the length. And now it says, how did the perimeter and area of the floors change from the first to the second doghouse? First thing we need to do is find the new perimeter. So perimeter again is 2 times the length plus 2 times the width. And so 2 times 4 plus 2 times 4. And so we get 8 plus 8, which is 16 feet. So the perimeter is now 16 feet. The area still is the formula, I always go to base times height, length times width, and that's 4 times 4, which is ironically also 16 feet squared. Now look at the differences between the original doghouse floor, so we're going to call this our original, and then the new. As far as the perimeter goes, the length around the doghouse, it only increased by 4 feet. Whereas the area of the doghouse increased by 8 feet. And so you notice that when we increased one of the lengths or widths, that it doubled our area, and that when we changed it, the same dimensions that we changed, it does not double our perimeter. So keep that in mind, that when we change it, just because we multiplied by 2 on the length, that doesn't automatically double our perimeter, but it did double our area. Alright, so it says changing dimensions effect on perimeter. If the dimensions of a polygon are multiplied by x, then the perimeter of the polygon changes by a factor of x. So figure A is a triangle that has 2 sides that are 3 and a base that is 2. And then figure B has 2 sides that are 6 and then the base that is 4. And so if you notice, each of these dimensions were doubled or multiplied times 2 to get to these numbers. Okay? It says the dimensions of figure A are multiplied by 2 to produce figure B. So when we find the perimeter of figure A, we're going to add up all the sides, because that's what perimeter means. We're going to add up all the sides, and we end up with a perimeter of 8. 8 units, whatever it is. And then when we do the same thing with figure B, we add up all the sides, and we get 16 units. So we have 8 units and 16 units. So basically, we've taken the perimeter of figure A and we've multiplied it times 2 to get the perimeter of figure B. Now this only works because all the dimensions of the figure must change. Okay? So for this to be true, for this to say, oh, we multiplied times 2 and so the perimeter is multiplied times 2, the only time that will work is if all of the dimensions of the figure change. That's called keeping it in proportion. Okay, keeping it in proportion. All of them change. Because if I had, let me just show you a picture here. If I had only doubled the base, but I left the sides as 3, look what would happen. I'd no longer have the same type of triangle. My triangle went from this to like a flat pancake triangle, okay? So it's not the same triangle. I didn't change it proportionally, so I'm not saying that the perimeter is double it. But if I changed all the sides accordingly, then we are doubling it. We're doubling the perimeter as well as each of the sides. All right. All right, I thought it'd be nice to have another example, so I'd like for you to have another piece of paper out so that we can take some extra notes. So go ahead and pause the video now and get that piece of paper, and when you come back, we'll copy this down. We have the old, or actually I'm going to call that the original. Let's call this the original. So we're always going to have our original and then our new shape, okay? And our original shape of our polygon, let's say, was 3 feet by 4 feet. Okay, so finding the area, or sorry, find the perimeter, we're going to take 3 times A plus 3 times B, meaning that A and B are each of the sides. So I'm going to do 2 times 4 plus 2 times 3. So I have 8 plus 6, which makes 14 feet. Now that's my perimeter of my original shape. Now I'm going to say, all right, let's change this up a little bit. Let's make it twice as big. So I'm going to take my original and I'm going to multiply each of the sides by 2. So my new base is going to be 8 feet and my new side length is going to be 6 feet. And notice that I'm not using height here because if I'm finding the perimeter, I'm looking for the outside of the shape, and that doesn't count this, I don't care about the height of it. I'm looking at the side length right here. So I just wanted to make sure I remind you of that. All right, so we've got 8 feet and 6 feet. We're going to set up our perimeter formula again. So we're doing 2 times 8 plus 2 times 6. 2 times 8 is 16. 2 times 6 is 12. And so our answer is 28 feet. So now we've said that the perimeter of the new shape is 28 feet. If I want to figure out what the relationship is between the two, here's something that we can do. We can take the new divided by the old, and that will show me the change of rate. Okay, so the new is 28, the old is 14, and so the change of rate is 28 divided by 14, which is 2. And lo and behold, same thing as this one. Now remember that this only worked because all of the dimensions were changed proportionally. I multiplied all the sides by 2, and that's the only way that it would have worked. I couldn't have left it as 3 foot and gotten the same response. Just because I doubled this one, If I didn't double this one as the side as well, then it's not going to work. It's not going to be double the perimeter anymore. All right, so let's go back. All right, so going back and using the same type of example, it says, suppose that the side lengths of a parallelogram are tripled. Okay, so this time we're going to say we're going to multiply it times 3. That's what tripled means, multiply it times 3. And so it wants us to find out what the effect would be on the perimeter. So going from our 3 inches, we would then have 9 inches as our slant height, and then 4 inches would become 12 inches. And so let's find our first perimeter. Let's find our first perimeter using the small one, and that's going to be our original. Okay, remember we're going to have an original and a new. And I'm probably going to go back and forth with calling it old. I don't mean to, but it's just how I always learned it. So 2 times 4 plus 2 times 3. 2 times 4 is 8. 2 times 3 is 6. And so together it's going to be 14 inches is the perimeter for the original one. Now we're going to do the same thing with our new parallelogram. We're going to find the perimeter of this one. So we're going to do 2 times 9 plus 2 times 12. We get 18 plus 24. When we add these together, we're going to get 42 inches. All right, so our perimeter for the new is 42 inches. Now, to find what the effect is, we're going to take the new and divide it by the original. So we take our 42 divided by 14, and what you get is 3. And lo and behold, that was what we had done, right? We tripled it. So what is the effect that it has on the perimeter? It also triples the perimeter of the original figure. All right, now let me have you do A. Make sure that you're doing your adding up all the sides. This doesn't have a formula really, it's just adding up all the sides for perimeter. And this time you're going to be multiplying it times 1/2. So go ahead and do A, and when you come back I'll go over the answer. Pause now. All right, so it says suppose the side lengths of the trapezoid at the right are multiplied by 1/2. So we originally had, and I'm just going to redraw it here. It originally had 13, so if I'm multiplying by 1/2, that really means dividing by 2, and so I'm going to have 6.5 centimeters. And then each of my sides will be 7 centimeters, and then my bottom will be 12 centimeters. So it's asking what the effect is on the perimeter. So that means I need to find the perimeter for the first shape, and then for the original, and then a perimeter for the new. All right, so for the original, we're just adding around. We're going to do 13 plus 14 plus 24 plus 14. All right, add those all up. And that's 65 centimeters. And then we're going to do the same thing. Let's see if I can... No, that's not what I want. Here we go. And for this, we're going to do the perimeter equals 6.5, trying to get that in there, plus 7, plus 7, plus 12. Remember, it doesn't matter what order I add them in as long as I get all 4 of them. And then that's going to equal 37.5 centimeters. And if I'm going to try and figure out what the effect was, I'm going to take the new divided by the the original. And so that's going to be 37.5 over 65, and you'll find that to be 1/2. And that's exactly what the difference is that we multiplied by that 1/2. Remember, since we did it to all the side lengths, we're good. All right, now as far as changing the dimensions, how it affects the area, This is another story altogether. So let's check this out. It says that if the dimensions of a polygon are multiplied by x, then the area of the polygon changes by x times x, or x squared. And that's a really big one I want you to remember. X squared, okay? So notice in figure A that we started with 5 and 4. And it looks like they multiplied both sides by 2, because now we have 10 and 8. Now, this doesn't mean, like with our perimeter, this doesn't mean that we're just going to multiply our area times 2. So we know this is base times height, 4 times 5, so we've got 20 units squared. Sorry, this is not easy to write. 20 units squared. We're not just going to times 2 and say that that's the area of figure B, because it's not going to work. You know that this area is not 40 units squared, right? Because it's 10 times 8. And so if I'm doing my 10 times 8, my base times height, then I'm going to have 80 units squared, which is not 2 times 20 units squared. I didn't take this area here and times it by 2 to get this one. Notice that I actually would be multiplying it times 4. If you take the new and the original, that's a multiple of 2, or sorry, that's a multiple of 4, which is actually this multiplying times 2 squared. So that's really the same as 2 squared, which we have here. So let's break this down. Why would we need to know this? Well, you could find the area for figure B without knowing these units. If they said, okay, I'm going to double all my sides, then we know that we can take the area of figure A and multiply it times 2 to the second power. And we'll get the area for figure B without having to figure out what these side lengths are. Now notice that all the dimensions of the figure must change using the same factor. So if I was only changing this, let me actually show you a picture. This is a really good picture. You'll go back to your pen and paper, separate paper again. So here's what we had in our picture, okay? Our original was the 5 by 4. Okay, pause so that you can fill this in, okay? Then we've got the new, which we know that we doubled the sides. Okay, if we double the side here, we're going to come out 5 more, right? And I just doubled my 5 so that I can make that 10, right? Well, if I'm doing the same thing with my other side, then I'm going to need to come up 4 more here to get my other 4 so that I can have the side length of 8. Well, we can't just leave this area blank. We actually are still looking at the area of an entire rectangle, and so I have to add in this space too. So notice instead of 1, I'm actually timesing it by 4. Interesting, huh? All right, so let's do another example because I like that one a lot. Let's just do a little thing like 2 to the third power. I didn't do that right. 2 by 3. Okay, just a little rectangle 2 by 3. And I want to multiply that times 3. I want to multiply both sides times 3. So we originally have, here's our original. We're going to multiply that by 3, going this way, so that our new length here is 9. Well, if we're doing it this way, we have to do the same thing this way. So here's 1, 2, 3, so that we get 6. Well, we have to fill in all these other pieces. We can't just leave it where it is and call it an L. We have to have all of them. So notice that I went from one box that was one size to 1, 2, 3, 4, 5, 6, 7, 8, 9 times this original size. Notice that that would be the same as 3 squared, isn't it? That times 9. All right. Now here's the thing. Without having to figure out my 9 and my 6, okay, keeping those blank and not even remembering them, I know that my area here is base times height, which is 3 times 2, which is our 6 units squared. I can take my 6 units squared, knowing that I'm going to triple each of the sides. I'm going to multiply that times 3 squared. So this is my figure A, and I want to find the area for figure B. And I want to ultimately multiply it times 3 squared, which is 9. So we have 6 times 9. So I already know without doing anything else that it would be 54 units squared to find this size right here. Now, we know that this was 6 and that this is 9, and that base times height would be 54. So check, okay? But this is why we go from one to the other. This is why we use whatever that unit is squared, because I'm stretching out this direction and I'm also stretching out this direction, and I want to not only find the outside, I'm not looking for the outside, now I'm looking for this inside space. That was a crazy drawing. You're welcome. So example number 2 says the side lengths of the triangle at the right are multiplied by 5. What is the effect this is going to have on the area? So if I'm multiplying everything by 5, then based on what I just said before, I'm going to take the original times 5 squared, and that's going to give me the area of the new triangle. So the area of this one, remember its area equals 1/2 base times height. That's another thing, is you won't have to do this formula again. You'll get to do 1/2 times base times height, cross simplify out our 2's, and so we end up with 1 times 1 times 1, which is 1. And so I'm going to do 1 times 5 squared is 5 times 5, which is 25. And so I know that the new area is 25 centimeters squared. And if you look over here, we've got our base times height, then divided by 2, it is 25 squared centimeters. So remember, this is what we're looking at right here. The original times however much we're multiplying by, and then we get the new. And if I want to work backwards and I want to figure this out, I say, okay, take the new divided by the original, and then that's 25, and what two numbers multiplied together that are the same make 25? That's going to be 5 squared. All right, a rectangle measures 2 feet by 4 feet. Suppose the side lengths are multiplied by 2.5. What effect would this have on the area? Justify your answer. So what would happen to the area? Would it change just by 2.5, or would it change by something else? Go ahead and try and figure that out based on the information that I gave you already. All right, so hopefully you figured out that it would be 2.5 squared, which is 6.25 times the original area. So we take the original one. If they wanted to know what the answer is, how much, the original comes out to, the new one comes out to, we ultimately will have area is base times height for a rectangle. So that's going to be 2 times 4, which is 8. So our original is 8. We're going to multiply that by 6.25, and that's going to give us our new area of the new rectangle. And that would be 50 feet squared. All right. And then example number 3, a stop sign is in the shape of a regular octagon. Sign A shown at the right has the area of 309 square inches. What is the area of sign B? So it says that we have a side length of 8 and a side length of 12. If I want to figure out what the difference is to go from here to here, I take the new and I divide it by the old, and that gives me my that's going to give me my multiplier, okay, which is going to be 1.5. Once I have that 1.5, if I want to find the area, and I know that this area is 309, I can take this multiplier, take my original times 1.5 squared, and that's going to equal my new answer, which luckily they've done all that hard work for us, is 695.25. All right, that ends our video. I hope that you enjoyed the lesson. Sorry it was so long this time, but it doesn't happen often. All right, guys, see you in school. Bye.